So what are the different ways we can measure revolutions? One way is just to say, oh, this object revolves this many times per hour, for example. Or we could also use, we could measure in degrees. That's where most people are comfortable. But in calculus, we tend to use radians a lot. And the reason why, so that would be the next natural question. Like in the previous problem where Carly and Daniel were kind of going off stage and the spotlight was following them, why, it doesn't say in the problem, oh, use radians or anything. Why is it automatically radians? That's the next question. Why do we always tend to use radian measures in calculus? In other words, why do we end up with radians when angle units have not been specified in the problem? And one of the key ideas is because radians, believe it or not, make it possible to relate a linear measure to an angle measure. So in other words, it's based on something that we measure in terms of length, right? So it relates to something that is measured in length. And it's a universal because it does not matter what units you use for that length in the circle. You can use centimeters, yards, feet. It really doesn't matter. This will be universal. And by that, I mean, if you think about how radians are actually defined, we have a circle here, and here's the center. 1 radian measure means that 1 radius fits inside. So the length of 1 radius. So for example, this length here, if this was 2 centimeters, this here would be 2 centimeters as long as we have 1 radian measure in there. So that means that 1 radii can fit within that circle. Now, if it had been a different size circle, for example, I made the circle even bigger. So let me go up here. Whoa, pretend like I could draw that. That's a terrible picture. But now I made the radius, here a little bit bigger. Now the radius of the outer circle here, let's call that 5 centimeters. Look, in here, this will still be 5 centimeters. So in other words, 1 radii can fit into that angle. So it's still going to be 1 radian. So in that way, I am relating a length to an angle. Whereas if we do degrees, it's just arbitrary. Someone said, and the reason why they use 360 is because 360 is easily divisible by many values, like 2, 3, 6, 5. So there's a reason why they picked it, but it is essentially just an arbitrary number that they chose for when we do degrees, whereas radians is universally true. In every circle, 1 radius can fit in here. That's it. No matter what size the circle is, even though you might be just as bad at drawing it as I am. So sorry about that. So that's why we use radian measures for in calculus, especially when it's not clear. Oh, what do you want to measure how the rate at which the angle is changing? It's always, even if it's not specified, radian measures per whatever time increment we're talking. Or else you have to specify. You have to say, oh, it's 1 revolution per hour. If I change that to radian measures, you would say it's 2 pi per hour. And that would probably be the first thing you would do in trying to calculate all the pieces if you were doing a problem that's specified in degrees. We want to change it back into radians because we're now relating an angle to a linear measure, and that linear measure is now always universally true, which is interesting.